So, I want to talk about measurements in physics. When I talk about fundamental quantities and their units, from the little explanation we already have, we know that the fundamental quantities, they are the quantities that are basic. They are the ones that are not compromised at all, and they are like 6 or 7. One of them is we have length. The symbol can be L, it can be L or D. It depends. And you understand what I mean. The other one is mass, which is going to be small m. Time, which is going to be what? T. Temperature, capital T. Electric current, equals to what? Capital I. Amount of substance, it can be N. Amount of substance can be N. When we are talking about chemistry, number of moles or something like that, or we call it Q. You get it? And another one is luminous intensity. Which is what? E. The unit for this is going to be in meter over, and it is in M. This one is going to be kilometer. No, mass. It's going to be in kilogram. Which equals what? Kg. The time is going to be in seconds, which is going to be what? S. And temperature is going to be in degrees Celsius, Kelvin, or Fahrenheit, or Rankine. But standard unit we use is Kelvin. Okay, that is standard unit. You know, when we are given something in degrees Celsius, we are going to convert it into Kelvin. And I, we have current is going to be in ampere, because of what? A. And the amount of substance is going to be in mole. You know, in chemistry, we have number of moles equals to mass over molar mass, is equals to what? M. And number of moles equals to number of substance over Avogadro's constants, or something like that. And I what chemistry indicates. This one with luminous intensity, which is E, we call it candela, which is equal to what? CD. That's the unit. These ones, all these ones, they are not compromised. They are the basic of the unit and quantity. These are the quantities. These are the symbols, I, T, M, something like that. And these are the units. Now, I want to talk about the derived quantity and units, symbols, and all those things. They are combined. They are the combination of these fundamental quantities. You can have 2, 3, or 4, or 5 of fundamental quantities that will make up derived quantities, and as well as the unit as well. So one of the examples is, the first example I will talk about is area equals to A. The unit area is going to be length times breadth. It can be length times breadth, it depends, or length times width. But it's going to be in meter multiplied by meter. That's the unit. We are concerned about the unit. Meter by meter. That's what the answer is going to be. The unit is going to be, sorry. And the unit for meter, the dimension analysis for meter is going to be L. You know, it is L. So this one is going to be L multiplied by L. So we have L square. So the dimension analysis for area is going to be L square. And I hope you understand what I mean by this. The second one, which is number 2, we have speed. Speed equals to distance over time. Our distance is going to be in form of d or time t. And our distance, unit for distance is going to be meter. Distance means the position from one spot to another over time in seconds. Now, the speed. The dimension analysis for this speed is going to be meter. Our meter is in L. Dimension analysis is going to be L. And t, what? Time. So this is now going to be t raised to power minus 1. So this is going to be dimension analysis. Please make sure you know this. Another one is derived. No, it's velocity. Velocity is going to be displacement over time. the displacement and distance are the same thing. The only thing that is different here is that this one is going to be in scalar quantity and this one is going to be vector quantity. They have the same units. So velocity is going to be meter over seconds. So the unit is going to be L t raised power minus 1. They are the same thing. The dimension analysis. So now the next one, lesson number 4, is going to be what? Density. Before we talk about density, we are supposed to talk about volume. Volume equals to what? Area multiplied by length. Our area is going to be meter times meter multiplied by our length, meter. So now this one is going to be length times length times length, like L times L times L. You know, dimensionality for M is going to be L multiplied by L multiplied by L, and we have 3L. So this one is going to be 3 raised by L. This is the dimensionality for the volume. Now density. Density equals to what? Mass over volume. That's the unit. So now density will now be equals to, what's our mass? Kilogram over volume, meter cube. That's the unit. So dimensionality for kilogram is what? M. Capital letter M. And dimensionality for this is going to be L cube. So you know this one is over. You now be that density will now be equal to what? M L t raised power minus 3. So this is going to be the answer. Number 6. So I want to talk about acceleration. Acceleration is equal to velocity over time. Acceleration A equals to what? V over t. What is our velocity? Velocity is equal to what? Displacement over time, which is equal to meter per second. That's the unit divided by seconds. So area will now be equal to what? Meter per second square. So what's our meter? L. What's our second square? T raised power minus 2. Because the reason why we have minus 2 is going to be because we have power. So this is going to be the dimensionality for it. So the next one is force. Force equals to what? Mass times acceleration, ma. What is our mass? Kilogram. What is our acceleration? Meter per second square. So now dimensionality for kilogram is what? Capital letter M, meter, L, t raised power minus 2. So this is going to be dimensionality for the force. Another one, 8. We have work done. You know, the work done is going to be force times distance. So FD. For the force, we have MA multiplied by distance D. So unit for mass is going to be kilogram. Acceleration is going to be meter per second square multiplied by D, meter. So we now have kilogram meter square per second square. So unit for dimensionality for kilogram is going to be what? Meter, capital letter M. For meter square is going to be L square. For second square per second square is going to be T raised by minus 2. So this is going to be the dimensionality for work done. And you know the unit of work done is what? Joule. Which is J or this. They are the same thing. I hope you understand it. Another one is energy. You know, energy is going to be what? It can be in form of in two forms. Energy can be in two forms. It can be in kinetic energy, which is equal to what? Half mv square, or potential energy, which is E potential equals what? Mgh. Dimensionality for this work done and this is joule. The unit for work done and energy is joule. So likewise is joule. This one too joule. So you have the same units, and dimensionality for both of them is going to be M L2 T raised power minus 2. ML2 T raised power minus 2. They are the same thing because they have the same unit. That's why the same unit makes them the same. Make them have the same dimensionalities. Now for pressure. Pressure equals to what? Force over area. That's the formula. What is the unit of force? Force is equal to what? MA over area acceleration. A capital letter A. Mass will be what? Kilogram. Acceleration is equal to what? Meter per second square. Over what's our acceleration? What's our area? Meter square. Meter times meter. When this one comes with this, we have kg per seconds all over. This one is what? Meter. So what's our k? What's our kg? Capital letter M divided by this L. This one t raised power minus 2 per seconds. Pi is minus. So you get. So this one will now be, this one is L over this one will now be M L raised power minus 1 t raised power minus 2. And this is going to be the answer for the poem. And I really hope you understand this. Now I want to talk about the units. I want to talk about unit in prefix and suffix. When we have 10 raised power minus 1, we call it decile, which is D. And when we have 10 raised power minus 2, we call it what? Centi, which is what? C. And when we have 10 raised power minus 3, we call it milli, which is what? M. When we have 10 raised power minus 6, we call it what? Micro, with this symbol. We call it micro something, like we have microfarad. When we are doing electrolysis in chemistry, we call it microfarad, and I hope you understand this. We have 10 raised power minus 9, we call it nano. So this one is going to be small letter n. And the last one I will talk about is minus 12. We call it what? Pico, which is what? P, small letter p. One thing I want you to understand is that all these that have minus, 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 they have symbol of small letters. Small letters. Small letters. Now, the ones that are going to be in positive ones, like now another one is the positive ones. 10 raised power 3 is going to be kilo. The unit, the symbol is going to be capital letter K, capital letter K. 10 raised power 6 is equal to what? Mega. Capital letter M. 10 raised power 9 equals to what? Giga. We call it what? G. And 10 raised power what? 12 is what? Tera. Like terabytes or something like that. And I really hope you understand all this. I wish you all the best. When you want to cover. No, we are going to be discussing that later. So another one is a conversion of units as well. Another one I want to talk about is a conversion of units. When we convert units, one of those things you need to understand here is this. You know that we have 60 seconds equals to 1 minute. 60 minutes equals to 1 hour. You have 24 hours equals to 1 day. Should be now. We have 86,400 seconds equals to what? 1 day. We have 7 days as 1 week. And we have 4 weeks equals to what? 1 month. And we have 12 months equals to 1 year. We have 52 weeks equals to what? 1 year. We have 365 days equals to what? 1 year. Please note all this. Note them very well. It's not something that you just be playing with like I have no need to. No it all. I'm saying my own. So now we now want to convert some units. Conversion of units as well. So we have 1 meter. It will be 3.281 feet. and 1 feet equals to 0.304 meter. You don't need to memorize these two. Shall memorize this one or this. When you memorize this one, 1 meter equals to 3.281 feet. When you want to find 1 feet, just divide 2 by 3 points. Just divide it by this one by 3.281 and this one by 3.281. You are going to have this one cancel this. You have 1 feet here, and this one will be equal to this in meter. That's all. So you don't need to memorize this. Another one is 1 meter equals to what? 2.54 centimeter. 1 meter equals to 2.54 centimeter. If you want to know, sorry for this, 1 inch. 1 inch equals to this. If you want to calculate 1 centimeter now, just divide 2 by 2.54. Divide by 2.54. So this one is going to be 0.393 in meter equals to what? 1 inch. Sorry. This one is when you divide this by this, 1 by 2.54, it will have in inches equals to what? 1 centimeter. And that's all. That's how you're going to be calculating it. Now, let me give you some typical examples. Let's say this one is an example. They say you convert 10 feet to meter. 10 feet to meter. If you are told to calculate. So one thing you are going to do is that 10 feet to x meter. Because you don't know it. Let's just use m. But the conversion for feet and meter to be 1 meter equals to this. Should be now. And 1 feet equals to 0.34 meter. Sure you get. You can pick any one. Sure you get. 1 feet. 1 feet equals to 0.304 meter. So when I cross this like this. When you cross this, you are going to have x multiplied by 1 equals to 10 multiplied by 0.304. So this one equals to x equals to what? 3.04 in what? Meter. So this is going to be the answer. The next question, they said example 2. They said you should convert 15 inches to centimeter. From the definition of inches, we have 1 inches to be 3.54 or 2.54. So 1 inches equals to what? 2.54 centimeter. So now 15 inches, we now equals to what? You can say y centimeter. So now you now cross multiply. You now have 1 multiplied by y equals to what? 15 multiplied by 2.54. So this one becomes y in centimeter will now equals to what? 15 multiplied by 2.54 will now be what? 38.1 centimeter. So this one is going to be the answer for this. And I really hope you understand what this question means. Now let me solve some questions that are in form of word problem for you. This is the question. The question says that Earth is approximately sphere of radius this. It said the radius of the sphere of Earth is 3.37 times 10 raised to the power 6. It's supposed to be times 10 raised to the power 6 meter. Then I said that what is the circumference? The circumference in kilometer. It is in meter. The first thing is that compared to kilometer is going to be divided by 1000. 10 raised to the power 3. So this 3 0 cancels this. So we now have radius to be equal to 6.37 times 10 raised to the power 3 kilometer. Now the first question, which is A, it says to calculate the circumference. Circumference of a sphere is going to be what? 2 pi r. That's all. So you now have C equals to 2 pi, which is 3.142, multiply by what is going to be the radius? This is going to be 6.37 times 10 raised to the power 3. When you multiply this, all this, your answer is going to be 40,029.08 kilometer. When you change this in index form, this one is going to be, this was 0. I want you to take it to the front. 1, 2, 3. So this one is going to be 40.03 times 10 raised to the power 3. You know, I took this dot in 3 places. Times 10 raised to the power 3 in kilometer. The reason why I turned this one to 3 is that because this 9 is up to 1. Is from the range of 5 to 9. So that's why I turned it to 1. I added this to 2. So you have a 3 as the answer like that. So B, the second question, they said you should calculate its surface area in square kilometer. Area of a square is going to be what? Pi r square. So now area will now be equal to what? Pi is what? 3.142. But like what is going to be 6.37 times 10 raised to the power 3 all square. So when you do this, you are going to have 127,4936 19.8 kilometer square. Now when I change this dot, when I turn to the index one, this is going to be migrated into 1, 2, 3, 4, 5, 6. So when I have 127.49 times 10 raised to the power 6 kilometer square. And this is going to be the answer for this. And the last one, it shall we should calculate the sphere. Its cubic volume cube in cubic centimeter. Volume is going to be what? 4 over sphere is 4 over 3 pi r cube. So the volume here is going to be 4 over 3 pi r cube. And we have V equals to what? 4 over 3 multiplied by what is our R? Pi is what? 3.142 multiplied by 6.37 times 10 raised to the power what? 3. All raised to the power 3. When you multiply this, the answer is going to be in approximated 1.0828 times 10 raised to the power 12 kilometer cube. That's going to be your answer. And I hope you understand what I did. Let me solve you another question. The next question states that this one, on an interstate highway in a rural region of Yoming, a car traveling at the speed of this is the speed 38.0 meters per second. Then after that, it's driving exceeding, is the driver exceeding the limit, the speed limit of this? The speed limit equals to what? 75.0 mil per hour. But they now say that from this explanation, it means that 1 mil equals to what? 1609 meter. One thing they are going to do is that this 75, one thing they are going to do is that this 75 mil per hour, you are going to calculate it in meter per second, and you find which one is greater. So when you have it, you are not going to know if it is exceeding the limit or not. If the driver is running faster or it is running lower. You know, 1 mil is this. So 75 mil equals to what? X. So this one equals this. So we have X equals to what? 75 multiplied by what? 1609. You know, your answer here is going to be in form of what? Seconds. But you have this into hour per hour. This 75 you have into hour. And when you convert your hour to minute from the question I did the last time when I was talking about minute and hour or time, you know, 1 hour is equal to 3,600 seconds. So when I want to find the number of seconds in this, you know, it is per, now be divided by. So your X now becomes what? 75 multiplied by 1609. divided by 3,600. So your x now becomes what? We now have 35.52. 33.52. So we now have 33.52 meter per second. Since we have 33.52 meter per second, it means that it is not speeding. The reason is that it is not up to this 38.0 meter per second. It means that it is not over speeding. It's a normal speed. And I hope you understand how to. Another question relating to what we are doing is this. They said a rectangular building has a width of this. The width W is what? 75 feet. And length is what? 125 feet. They now say that determine the area of this lot in square meter. Now, when you want to determine the area A is going to be L multiplied by W. So it's going to be 75 multiplied by 125. So what you want to calculate this area first in feet. You now convert it to what? Meter. So we now have 75 multiplied by this. But they told you that 1 feet. But they told you that 1 feet equals what? 0.3048 meter. So you know you are taking to meter. Now take this to meter. We now have 75 times 125 feet. Then because of what? X. When this one comes multiplied like this, x now because of 0.3048 multiplied by 75 multiplied by what? 125. So that is how you are going to calculate your answer. So this one is 2857.5. So in what? In meter square. And this is going to be your answer. Another question relating to what we've been doing before is it said a solid piece of land, this land, forget it, land, has a mass of this. They said the mass is what? 23.94 gram. And a volume of this, volume is what? 2.10 centimeter cube. From this data, calculate the density of land in SI units. You know, SI units is going to be kilogram per centimeter cube. This one is supposed to be in kilogram. This one is supposed to be in centimeter cube. You know, density is what? Mass over volume. The first thing you are going to do is that to convert this into kilogram. When you convert gram to kilogram, it's going to be divided by 1,000. So this one is going to be 23.94 divided by 1,000 in kilogram. That's first thing. Another one, volume. When you convert this volume in centimeter cube to meter cube, so this one is going to be 2.10 divided by, you know, centimeter to meter is going to be multiplied by, is it going to be multiplication? Is it going to be divided by 100? Divided by 10. It's going to be divided by 100. Divided by 100. So this one is going to be in centimeter cube. This one is going to be divided by 100. So, you know, this one is now in meter cube. Now, from centimeter to meter, it will divide by 100. Now, this one has a cube. So, centimeter cube now, we now cube this. So, this one will now be 10 raised to power 2 multiplied by 3. So, we now have 2.10 divided by 10 raised to power 1 times 10 raised to power 2 all raised to power 3. We now because of volume now because of 2.10 divided by divided by 1 times 10 raised to power 6. So this is how we are going to do this. And you know density is because of what? Mass over volume. What is my mass? mass is this 23.94 divided by 1000. Now this one is divided by, so when I want to divide this, I will not change the multiplication. It will now be multiplied by 1 times 10 raised to the power 6 divided by 2.10. So 1, 2, 3. This one comes to 3 here. We have 1 10 raised to the power 3 here. 3 will cancel to 6 here. You know we have 6 zeros. When it cancels this 3 0, we have 3 0 remains. So we now have this one now remains density now equals to what? 23.94 multiplied by 123 divided by this one 21.10. So I now have 23.33940 divided by 2.10. And I hope you understand what I did. So the answer to this is going to be 11400. So this one is going to be 11400. You know, the question states that we should calculate it in meter per second cube. So density will now be equal to what? 11400 mass over volume. And this is going to be the answer. I wish you all the best. I think we are going to stop here. So I wish you the best.